Welcome to our YouTube channel. This is Ernest coming to you from MathLab Tutorials in Toronto, Canada. Although seemingly impossible, our mission is to transform some of that destructive hate energy into constructive love energy. Mathematics is part of all that surrounds us. Just pause and take a good look. As your screen suggests, like it or not, math really did take us from the Stone Age to the Space Age. The sermon is over. Now let's get down to some serious math. This is a continuing series on algebra, and this will be video 6 of the series and essentially a continuation from video 5. And without further ado, let's have a look at part D over here. And the first thing I notice is that we have two clusters. We have a cluster here. The separator is the minus sign. So if there's a separator of a minus sign or a plus sign, we have two clusters on our hands. Okay, so this is an addition and subtraction problem involving rational functions. Okay, you'll recall that a rational function is just a quotient of two polynomials. If we look at the first cluster, we have a linear term on top. On the bottom, we have a quadratic term. If we look at the second cluster, we have a linear term and a quadratic term on the bottom. The first idea is to look at each cluster and factor everything that you can possibly factor in each cluster. Of course, the 4x is linear, nothing to do. This over here is quadratic, and it factors as 3x plus 2, 2x plus 3. You can verify by expanding that. It will expand to the original. And of course, 3x is linear. You just drop it down. The minus sign, don't forget about that. And 4x squared minus 9 is just a simple difference of squares, which factors as 2x minus 3, 2x plus 3. Okay, so later on in this video, we'll be talking about how to factor problems like these, which I called hard trinomial factoring, but let's leave that until a little bit later. Let's continue with this. Look for any internal cancellations. There are none. Look for any internal cancellations. There are none. Okay, now we look for the LCD. We certainly need a 3x plus 2, drop it in. We need a 2x plus 3, drop it in. We certainly need a 2x minus 3, drop it in. And 2x plus 3 is already there, so it would be redundant. You don't want to drop in another 2x plus 3 because we don't need it. We could, but then that wouldn't be the LCD. You want the LCD to be the leanest possible product of factors. Okay, so you leave out the second 2x plus 3 because that would be redundant. So now that we've identified this as the LCD, in the next line, draw a big division bar, pick up the LCD, put it in the denominator, and now for the numerator, we do a 4x empty bin, pretend like this bin is empty, and then a minus 3x empty bin. And the idea now is to fill in the bins. And the way I explained in the previous video, the easiest way to fill in the bins is to compare the old denominator to the new one. When you compare this to this, what's missing is the 2x minus 3. And so you drop it inside the bin. This is the one that's missing. Drop it inside the bin. When you compare the old denominator to the new one, what's missing is the 3x plus 2. So you pick up the 3x plus 2 and you drop it inside the bin. At this point, you want to expand the numerator and collect like terms. Expand the numerator and collect like terms. As indicated previously, the denominator remains intact. Please do not expand the denominator because it's going against the grain. You're doing the math a grave injustice by doing that, and you're doing yourself a grave injustice because when you expand the denominator over here, you'll get a cubic polynomial that at some point in time you're going to have to refactor in order to obtain the restrictions for this problem. Do not expand the denominator, only the numerator. So when you expand the numerator, you get a 4x dot 2x is 8x squared, 4x dot negative 3 is minus 12x, minus 3x dot 3x is minus 9x squared, and minus 3x dot 2 is minus 6x. In the next slide, what you want to do is collect like terms here. And when you collect like terms, you get a minus x squared minus 18x. The denominator remains intact. Do not touch it. And we look at the numerator and we conclude that the GCF is minus x. So you can factor out a minus x in the numerator. When you do that, you get minus x bracket x plus 9. And the denominator is just a copy paste. Do not expand. This will be the end of the problem. This is the reduced form. And at the end, you have to impose restrictions. If you go through the solution to this problem again, you'll notice there were no cancellations that were made. So there are no cancellation restrictions at all. So certainly no one will ever go to jail. However, at the end, you look at the denominator. You want to make sure the denominator is not equal to 0. To ensure that, you have to ensure that each factor is not equal to 0. Notice there are no cancellations here, top to bottom. So 3x plus 2 not equal to 0 means that x is not equal to minus 2 over 3. 2x plus 3 not equal to 0 means that x is not equal to minus 3 over 2. And 2x minus 3 not equal to 0 means that x is not equal to 3 over 2. Okay, so these are all the 1 over 0 restrictions. If you violate any of these restrictions over here, it's instant death. Okay, so we don't want anybody to die. So make sure you do not violate these restrictions. So this is a perfectly acceptable reduced form, provided you impose these restrictions. Okay, there are no cancellation restrictions for this problem. So let's go on to the next slide. And I think from here on in, the subsequent slides is all about factoring. So this is where I'll get into some more details regarding the way I factor various types of expressions. Okay, so we look at question 1b. It says use the GCF, greatest common factor, to factor. Okay, over here we see a binomial. 2 terms means binomial. The separator is the minus sign. So you can think of a binomial as 2 clusters. Okay, and the idea, we've been through this before, is to look at the coefficients first, 6 and 9. You conclude that the GCF is 3 between 6 and 9. Look for the lowest power of x, it's x squared, so that's part of the GCF. Look for the lowest power of y, that's y cubed, so that's part of the GCF as well. So the entire GCF is 3x squared dot y cubed. Okay, so over here I indicate that the balance is always the term divided by the GCF. Okay, so here's a little legend over here. The balance is always the term divided by the GCF. I call this a balance formula. B stands for balance, T stands for term, and GCF stands for greatest common factor. So there's a GCF over here. We found it up here. We drop it down. Our mission is to find the balance, B. To find the balance, you do term divided by GCF. 6x to the power of 4 dot y cubed divided by the GCF will give us a 2x squared. And minus 9x squared dot y to the power of 5 divided by the GCF will give us a minus 3y squared. Okay, you can do that slowly if you want. All you're doing is using exponent laws, really. Okay, so our balance is 2x squared minus 3y squared. If you ever need to verify your factoring, all you have to do is re-expand. Okay, we can use a bullet and 2 targets to re-expand, and if you do that, you'll easily get the original problem. Okay, you can do it yourself, or here we'll do it now. 3.2 is 6, there's a 6, x squared dot x squared is x to the power of 4, and then you have a y cubed. That's the bullet with the first target. Then we have a 3 dot minus 3 is minus 9. X squared is just x squared, and y cubed dot y to the power of 2 is y to the power of 5. And again, if we use a bullet, target, we can recover the original. Okay, let's go on. So that's a little GCF factoring problem. Okay, again, I rewrote this legend, so I don't need to go over it again. Here's another problem down here. We have a 5 bracket 2y minus 1. Originally, it did not have the square brackets or the box around it. That was just to illustrate. And then minus 3y bracket 2y minus 1. If you look over here, this is like the first cluster, and this is the second cluster. The separator is the minus sign. So we're looking at 2 clusters altogether. If we look at this cluster, the GCF is actually 2y minus 1. Okay, 2y minus 1, 2y minus 1. That's also called a common factor. Okay, so we can certainly factor out a 2y minus 1 as GCF. So as usual, we write the GCF out front. And now what remains after we pull the GCF out front is the 5 and then minus 3y. So we get a 5 minus 3y. So the balance is quite easy. Okay, all you do is wipe out the GCF, pretend like you can erase this, erase the GCF. The balance which is left over is 5 minus 3y. And that's the factored form. Let's go on to the next slide. It says use factor by grouping. FBG is short form for factor by grouping to factor. And if we look at the question, we have 28u dot v minus 8u minus 21 dot v plus 6. The first thing I notice is that I have 4 terms. And usually 4 terms means that you use factor by grouping. That's the rule of thumb. If you get 4 terms, factor by grouping. And the idea is to group the first 2 and the last 2. That's why I wrote down F2, L2. Group the first 2 and the last 2 and see if we can get a common factor by doing that. So how do we group? By putting a set of brackets. So we drop the first 2 terms down. We open up 2 empty bins. That plus that. We drop the first 2 terms inside the empty bin and then the last 2 terms inside that empty bin. Okay, so we have a first group and a second group. 2 groups or 2 clusters. Okay, so now the idea is to look at the first group and only the first group and factor out the GCF. Okay, we find that the GCF of the first group, the GCF of 28 and 8 is 4. And also the lowest power of u is u, and that's it. That's the GCF. And then when we do term divided by GCF, we get 28 divided by 4 is 7, and uv divided by u is just v. And then we'll do term divided by GCF again, minus 8u divided by 4u is just minus 2. Okay, over here the GCF for this, we can either take out a 3, okay, because 3 divides into 6, divides into 21. But if you're really smart about it, you'll take out a minus 3. Okay? If you take out a 3, it's just an extra step. If you take out a minus 3, you're good to go right away. When you pull out a minus 3 as a GCF from the second group, the balance becomes 7v minus 2. You get minus 21v divided by negative 3 is 7v, and 6 divided by negative 3 is minus 2. So why did I factor out a minus 3 instead of a plus 3? So I can have a common factor. 7v minus 2, 7v minus 2, it's a common factor. If I would have pulled out a plus 3 instead, this would have been minus 7v plus 2. Then you wouldn't have a common factor. So the idea behind factor by grouping is to obtain a common factor between the 2 groups. Okay, so we look at this carefully. We identify the common factor as 7v minus 2. and we put the common factor out front, and now we look for the balance. To find the balance, the easiest way to do it is to erase the common factor. Erase the common factor. What's left over is a 4u minus 3. So erase, erase, you're left with a 4u minus 3. And that would be the balance. And that's the factored form. So that's a little example of factor by grouping with 4 terms. Let's go on to the next slide. It says over here for 4j, use the GCF, greatest common factor, and factor by grouping, FBG, to factor. So you always, when you have an expression, the first thing you always look for is to factor out a possible GCF. Always. I can't overemphasize that. Look for the GCF first. Okay, so how many terms do we have over here altogether? We have 4 terms. So it looks like it might be a factor by grouping because we have that magical 4 terms. Look for the GCF first. Okay, so if we look at, we get a 2, 2, 2, 2. Oh, 2 must be part of the GCF. Then let's look at the lowest power of a appearing everywhere. This is a squared, a squared, a. So the lowest power of a is a. Let's look for the lowest power of b. We have a b, b, b squared, b squared. The lowest power must be b. The lowest power of c. We have a c squared, c, c squared, c. The lowest power is c. And the lowest power of d, we have a d, d squared, d, d squared. The lowest power is d. So the entire GCF is 2.a.b.c.d. And all we do is put the GCF out front as usual. And now our job is to figure out the balance. And as usual, the way we figure out the balance is to take each term and divide it by the GCF. So if you look at the first term over here and divide it by the GCF, you'll easily find you get an a.c. If you look at the second term over here and divide it by the GCF, you'll easily get plus a.d. And if you look at the third term divided by the GCF, you'll easily get minus b.c. And if you look at the fourth term divided by the GCF, you'll easily get a minus b.d. Okay, so that's how we factor the GCF and how we obtain the balance. Okay, now you look inside the brackets. GCF is done. From here on in, it just goes along for the ride. Notice it just gets dropped down. You don't do anything with it. The idea now is to look inside this bracket here. When we look inside the brackets here, we notice 4 terms. The idea is to group the first 2, last 2. First 2, last 2. So we form 2 groups. How do you form a group? Just put brackets, empty bin plus empty bin, drop the first 2 in, the last 2 in. Then look at each group and factor out the GCF. That's what I did over here. The GCF of this group is just A. We're left with a balance of C plus D. If we look at this group over here, the GCF is certainly minus B. So we pull it out, and the balance is C plus D. Lo and behold, if we compare, we get a common factor over here of C plus D. That means we can pull it right out front and put it right beside the GCF that we found before. Recall that this was the original GCF, and there's the common factor C plus D. When we erase the common factor over here, we're left with a balance of A minus B. So we write down A minus B as the balance. So there's the factored form right there. The original GCD was that. Then the common factor due to factor by grouping was C plus D. And this is the balance due to factor by grouping, and it's A minus B. So this is the factored form. And SpongeBob over here says, yay. Okay, so let's go on to the next slide. Okay, this is the very first time I ever mentioned ETF. ETF is short form. It's a form that I came up with so that you would recognize easy trinomial factoring. Easy trinomial factoring, ETF. And easy trinomial factoring occurs when you have a quadratic, like x squared plus bx plus c. It's certainly quadratic, but the a is missing. Okay, the a term is missing. It's not really missing. The a term is equal to 1. Don't forget that a, b, and c are the quadratic coefficients. But when the a term is equal to 1, I call it an easy trinomial factoring because it's fairly straightforward to do. Okay, here's the question at hand. It says factor x squared plus x minus 6. The coefficient of x squared is 1, so we identify that as an ETF problem. And the b and the c are 1 and minus 6. So there's b and c. You put 1 and minus 6 down here. And the idea is that we're looking for two numbers that add to give you b, and they multiply to give you c. So we're looking for two numbers that add to give you 1, and they multiply to give you negative 6. Okay, you do this part, you do the c part first all the time. Two numbers that multiply to give you 6 are 2 and 3, so it's 2 times 3. But now they have to add to give you 1. So it must be minus 2 plus 3, which will give you 1. So do the multiplication first and then confirm the addition. Okay, so that's what we're going to do. We did the multiplication. 2 times 3 is 6. And then we need a minus sign to get negative 6. But you don't know whether the minus sign goes with the 2 or the 3. Okay, it has to go with the 2 because these two boxes over here have to give you 1. If the minus sign went with the 3, you get 2 minus 3, which is negative 1, and that's no good. Okay, so you're looking for two numbers that multiply to give you a negative 6, and they add to give you 1. Okay, so now that we have this negative 2 and 3, it becomes easy. In the next line, you open up an empty bin, put down an XX, and then drop in a minus 2 in here, and drop in a plus 3 in there. Okay, make sure to carry the signs. This is minus 2, drop it in there, plus 3, drop it in there. It doesn't matter if you drop the 3 in that one, drop the minus 2 in that one. The order of the factors is irrelevant. It's completely up to you, but this is the factored form. If you re-expand this using 2 bullets and 2 targets, you'll easily get the original. X dot x is x squared, x dot 3x is 3x, and then we have minus 2x, 3x minus 2x is x, there it is. And finally, minus 2 times 3 will give you negative 6. So voila, and we're done. That's basically how easy trinomial factoring goes. Okay, let's look at another question. This is question 6e. It involves like a GCF then times an ETF. GCF times an ETF. So we're going to have something of the form GCF times, and there's an ETF there because the A value is 1. Okay, so this is the actual question right here. 3g squared minus 6g minus 72 is certainly a quadratic trinomial. And the first thing you look for is factoring out the GCF. 3, negative 6, negative 72. The GCF is 3. And so you put the GCF out front and you divide to get the balance. Okay, 3 divided by 3 is 1. There's the g squared term. Minus 6 divided by 3 is negative 2. There's the minus 2. Minus 72 divided by 3 is minus 24. Now the GCF just stays out front. And over here we identify this as an ETF. There's the ETF right there. What's the coefficient of g squared is just 1. So you identify that as an easy trinomial factoring. The A value is 1, the B is negative 2, and the C is negative 24. So at this point, you set up your little chart over here with B, C, add, multiply. Okay, so we need two numbers that give you that add to give you a negative 2. So you just drop the negative 2 down and drop the negative 4 down over here. We're looking for let's do the multiplication first. Two numbers that multiply to give you 24 is certainly 4 and 6, but then you need a negative. So it's either 4 times negative 6 or negative 4 times 6. We have to decide. It's got to be 4 times negative 6, because when you add these two boxes together, you must get negative 2. And 4 minus 6 is negative 2. However, minus 4 plus 6 will give you 2. No good. Okay? So the first thing you do is look at the 24. Think of two numbers that multiply to give you 24 and add or subtract to give you 2. The two numbers are 4 and 6. Then you say to yourself, oh, but that's negative. So it's either negative 4 times 6 or 4 times negative 6. Okay? 4 times negative 6, when you add them, you'll certainly get a minus 2. But minus 4 plus 6 will give you a positive 2, which is no good. So that's how you know for sure. And in the next step over here, you drop the GCF down, which is 3. Open up an empty bin, .empty bin, put in a GG, and then grab these numbers and drop them inside the bins. So we get a plus 4 here and a minus 6 in this second bin. And SpongeBob says that we're done. Okay, so let's have a look at the next question. This is the same sort of question, but it looks quite a bit harder. Okay, but believe me, it's the same type of question. It's a GCF.ETF problem. Again, it illustrates it better over here. GCF times ETF. Again, ETF is when the A value is 1. Okay, so let's look at the question over here. This is the first term, second term, third term, so it's definitely trinomial. But it looks like a bit of a mess. So let's try to see whether we can factor out a GCF from this. Okay, if we look at 2, negative 4, negative 30, the GCF is 2. The lowest power of x I'm looking for, you get x cubed, x squared, and x. The lowest power must be x. And the lowest power of y, we have y squared, y cubed, y to the 4th. So the lowest power is y squared. That's part of the GCF. And then the lowest power of z, we have z cubed, z cubed, z cubed. Lowest power must be z cubed. So we just finished building the GCF. So the GCF is 2x.y squared.z cubed. And we put it out front. Now the next step is to obtain the balance. And the balance we always get by doing term divided by GCF. If we look at the first term divided by the GCF, look at it carefully, the balance is x squared. If we look at the second term divided by the GCF, the balance is minus 2xy. Okay, you can do that carefully if you want. When you do term value divided by GCF. When you do the third term over here divided by the GCF, you'll easily get minus 15.y squared. So the GCF remains out front. And now if we look at this carefully, we actually have a quadratic over here. It's trinomial. It's quadratic in two variables, x and y. There's the x squared, there's the y squared. So this is a quadratic in two variables. Okay? But if we think about this as a quadratic only in x squared, then this will be the x squared term, that'll be the x term, and that'll be the constant term. If you look at the coefficient of x squared, that would be the a value. It's equal to 1. So we identify this as an ETF. We go over here to the little chart, BC chart, and we drop in a negative 2 and a negative 15. There's negative 2 and negative 15. And again, do the multiplication first. We're looking for two numbers that multiply to give you negative 15, and then they add to give you negative 2. And certainly 3 times negative 5 will give you negative 15, and 3 plus negative 5 will give you negative 2. So that must do the trick. So in the next line over here, just copy paste the GCF, put it down, and put down empty bins. Now, when you put down empty bins now, put an X, Y, X, Y. Do not fill in the numbers. You put in an X blank Y, X blank Y. The numbers go in between. Put a 3 there and put a negative 5 there. But don't forget, because this is a two variable quadratic, You put an x, y, leave the in-between blank, x, y, leave the in-between blank. Grab the numbers that you found over here, grab the 3, insert it in there, grab -5, insert it in there. When you look at this, this becomes the final answer, which is the factored form. Okay, we have a GCF out front, we have a linear factor in x, y, and we have a linear factor in x and y over here as well. So that will constitute the factored form. Okay, let's go on to the next slide. Question 7a will be our first question that deals with HTF, and HTF stands for hard trinomial factoring. Okay, so hard trinomial factoring. It's a little bit harder than ETF. You'll recall that ETF is the case where a is equal to 1. HTF is the case where a is not equal to 1. Okay, it could be a number like 3, 4, 5, etc. Okay, so this is the more difficult case. The procedure is a little bit different. Okay, so let's have a look at this problem right here. We have 18x squared minus 9x minus 20, and that's what we want to factor. The first thing you look for is a GCF. If we look at the coefficients 18 minus 9 minus 20, there is no GCF. So there's nothing to do there. In the next step, you open up an empty bin, leave it empty. Okay? Leave it completely empty. Don't even put the x's down. Okay, here we go. This is what we do to resolve hard trinomial factoring problems. I do like an ABC chart. The A is 18. These are the quadratic coefficients. The A is 18, the B is -9, and the C is -20. Just put them down in the header over here. I box in the objective. The objective is the B this time. Underneath the A, I list all the factors that multiply to give you 18, but I list them in order. I do 1 and 18, certainly multiply to give you 18, and then 2 and 9 multiply to give you 18, and 3 and 6 multiply to give you 18. And that's it for the factors. Now, look at -20. Disregard the minus sign. Right now, the minus sign is irrelevant. Just think about the 20 and only the 20. And we're looking for all the numbers that multiply to give you 20. So we have 1.20 is certainly 20, 2.10 is 20, and then 4.5 is 20, and we're done. We've exhausted all the numbers that give you 20. Again, you notice the order that I do them with. This always starts off with a 1, and then you proceed upwards. Starts off with a 1, and you proceed upwards. As you proceed upwards on top, the part on the bottom proceeds downwards. So 1, 2, 4 is ascending, and 20, 10, 5 is descending. 1, 2, 3 is ascending, and 18, 9, and 6 is descending. That's the way I like to do these. Now the objective, we're not done yet. The objective is to match a left set of brackets to a right set of brackets. Okay, and the objective is to get a -9. Okay, that's why I box that -9 in. So we'll try the bottom two first. Okay, now what do? We multiply. Let's try 3 times 4. It's 12. 6 times 5 is 30. Is there any way to add or subtract 12 and 30 to give us 9? Forget about the -9. Look, let's do it again. 12, 3 times 4 is 12, 6 times 5 is 30. 12 and 30. Is there any way to add or subtract 12 and 30 to get 9? The answer is no. Now you try crisscross. We did parallel. We did our parallel try. Now we try crisscross try. 3 times 5 is 15. 6 times 4 is 24. Is there any way to add or subtract 15 and 24 in order to get 9? And the answer is yes. Okay, so you've hit the mark. 3 and 5, 6 and 4. You put down 3 times 5 is 15. Put it down. Don't worry about the plus sign. 6 times 4 is 24. Put it down. Don't worry about the minus sign. Okay? So now you've got 15 and 24 over here. You know that these have to add to give you negative 9. Okay? The only way these can add to give you a negative 9 is if this is a negative and that's a positive. So we have a negative 24, positive 15. Now, one more thing. We're almost done. One more thing. When you multiply these signs, it has to be the same as the sign of C. So what's a negative times a positive? It's negative, and that's negative as well. So we're good to go. That's how you know you nailed the factoring. Okay? The signs have to multiply to give you the same sign as C. Now we're finished with this over here. We need to know how to put the numbers down over here. Okay? Notice we did a crisscross over here. We went 3, 5, 6, 4. Okay? To put the numbers down, you always have to do the opposite of what you did over here. If you did a crisscross over here, you do a parallel when you put the numbers down. So you put down 3x and then a 4. You put down 3x4, forget about the minus sign. And then you do a 6x and 5. 6x and 5, forget about the minus sign. Okay, let's go over that again. Remember we did a crisscross. We did 3 times 5 will give us 15. We did 6 times 4 will give you 24. And we figured out the correct signs over here. And now we got to figure out how to put it down inside the brackets. Since we did a crisscross over here, when you put it inside the brackets, you have to do a parallel. Okay, we do a 3 and 4. So this will become like a 3x and 4. And we do a 6x and 5. You always have to do the opposite of what you did over here. If you did a crisscross, then you have to do a parallel when you're putting it down. If you did a parallel over here, then you have to do a crisscross when you're putting it down. Okay, it's always the opposite of what you did to get these two numbers over here. Okay, so now we know we did 3 times 5 and 6 times 4. So we do a 3x and 4, drop it in. And we do a 6x and 5, drop it in. Do not put the negative, do not put the positive. Okay, at this stage, you do inside, outside to figure out the signs. Okay, when you do the inside, you get 4 times 6, which is 24. And we need negative, so that must be negative 4. When you do the outside, you get 3 times 5, which is 15. And we need positive, therefore that must be a plus sign. Okay, so that's how you factor hard trinomials using chart factoring. I call this chart factoring for HDFs. Chart factoring for HDFs. That's like an ABC chart for an HDF. Anyway, it's going to take you some practice to get this method down. But once you get the method down, you're good to go. Believe me, you need some questions to practice on. Okay, let's go on to the next slide. And you know what? I think this is going to get a little lengthy, so we're going to do an over and out, and I'll see you in the next video. Thanks to all for viewing this video. Stay tuned for many more videos to come. If you liked the video, please give us a like, submit comments, and subscribe to our channel. If not, tell us how to improve it. Over and out from MATLAB Tutorials in Toronto.